Alright, so this problem is finding the roots of a quadratic equation with leading coefficient of 1. So if you were to have something like w squared plus 10w plus 25 equals 0. When they're saying roots, what they're really just asking for is what's the value in this case of w, okay? That's all they're asking for. So a root is just simply a solution or an answer. Okay, so that's all a root really is in a nutshell. Okay, so again, I could rewrite this as x squared plus 10x plus 25 equals 0. And when they're asking for a root, they're simply just asking what's the value of x. Alright, so with that, let's just go ahead and look at some methodologies here for solving this. One of the methodologies that you guys are familiar with is the box method. Okay, and then there's another method over here that I'll show, which is the factor method, which is pretty much the box method, just written slightly differently. So the box method would be to draw this out. We know that the first term will go up here. We know that the last term will go over here. And we know that the addition of the terms in these two boxes have to be equal to 10w. And we know that the multiplication of what's in those two boxes has to be equal to 25. So this is the multiplication portion of it. And the blue is the addition portion. Okay? So for 25, let me go ahead and write 25 off to the side here real fast. I know that 25 is 1 times 25 as well as 5 times 5. Well, I know 1 plus 25 is 26 and 25 minus 1 is 24. So these factors will not work, leaving us with 5 times 5. Well, that makes sense because 5 plus 5 is going to be, is going to be 10. Now remember, this is w and this is w, right? Let me actually erase those and get back to this w. So we got w and w here. Okay? So now we got our 5 w's. What we need to do is we need to fill in some of the pieces on the outside here of the square because we're looking for a length and a width. Basically what you see here is the fact that we have length times width is the sum of all these areas, and the w squared plus 10w plus 25 is just the area of this square. So what we're going to do is we're going to factor out terms that are the same here. Okay, so I have w squared and w. Well, the only term that's common here is going to be w. And if I look across this way, 25 and 5w, the only terms that, the only components of these terms that are the same is going to be 5. 5 is a thing that I can factor out of both of those. So we have w plus 5. Now let's go vertical. 5w, w squared, that's a w. And 25 and 5w, I can factor out a 5. So what I have here is w plus 5 times w plus 5 equals 0. So the roots of this quadratic equation with a leading coefficient of 1 would be, if I had, this would now be w plus 5 quantity squared equals 0. I would square root both sides to get rid of the square, so those are gone. And now I'm left with w plus 5 equals 0. Which means I need to get w alone, and so I'm going to subtract 5 from both sides, and so I know w equals negative 5. And so the root of my equation is negative 5. If I were to plug this number back into my original equation, I would actually have 0 equals 0. Hence, we would know it would be true. With that in mind, let's go over to the factor method. Okay, so we've got w squared plus 10w plus 25. Let me go ahead and rewrite that. W squared plus 10w plus 25 equals 0. What I'm going to do is I'm going to go, okay, I know this is 5 times 5, and that this is w times w. I'm going to create two baskets. There's a basket, there's a basket, and I know this has to be equal to 0. Because these are up front, I put them in the front, W and W. Because these are at the back, I put them in the back, 5 and 5. Due to the fact that this is a positive and that's a positive, we know both of these terms will have to be positive. This leaves us with W plus 5, quantity squared, equals 0. And again, we follow the same process of square rooting, and getting W plus 5 equals 0. And I know that W is going to have to equal -5 in order for this to be true. Okay? So, two processes. You're more familiar with the box method, but there is a factor method that's also available to you.